Welcome. Let's begin with the strings internal representation in Python 3. So in Python 3, by default, strings are represented in Unicode. As we can see here, even the Python file in Python 3, it is stored as a Unicode, each character. Okay. So why we need that encoding method? So as we can see, the data are in a textual form. Okay, but computer understands only binary 0 and 1. Okay, so while storing the textual data to a file or transferring that data over the network, it needs to be converted into the binary. Okay, so in order to convert those textual data into binary, different kinds of method are used. Those different methods are called as a different encoding method. So this is Unicode is a one of the encoding, okay, which maps the given character to its binary representation. So for different encoding schema, their internal representation in binary for that particular certain character could be different. Okay, so Unicode is the most popular encoding which represents characters and symbols of different languages. Okay, and normally the characters are mapped with using of hex value, which begins with hexadecimal escape \x, and for Unicode escape \u. ASCII is also one of the encoding which only supports English letter and numbers and symbols. Okay, so comparing to the Unicode has very wider coverage of character. It supports multiple language and their numbers and symbols. Okay, and in ASCII, each character is encoded using 1 bytes. Means only out of 1 byte, only 7 bits are used to represent a single character. So each character, if we talk about their integer value, ordinal value, they are represented between 0 to 127. Okay, in Unicode it is represented into the hexadecimal value, as we will see as we go on. Okay, so in order to convert the given character into its ordinal value between the given range, ORD method is used. So if we pass any character of ASCII, then it will represent its integer equivalent of that character. So if we execute it, as we can see here, capital A is represented as 65, capital B will be represented as 66, up to Z, which is represented as 90. Same for small letter, starts with 97 and goes up to 122 in ASCII. Okay, same in order to convert from the given numeric or ordinal value to character, CHR method is used. Okay, so if we give 65, it will convert it into the capital A. Let's execute it. As you can see, 65 is converted to capital A, 97 is small a, and so on. Now next method is hex, which converts the given ordinal value or an integer value to equivalent hexadecimal value. So if we take ordinal of A, which will return, as we can see, 65, and for 65 it will convert it into the hex value. Okay, this hex will be useful when we are using Unicode data. Okay, so as we have explained earlier, encoding is a method which converts the given strings into their equivalent binary representation according to the encoding schema given. So for that encoding, encode method is used. It takes one argument, which is the name of encoding method used for mapping. Okay, so converted string will be called as a byte object or a byte string. Okay, so if we have string, suppose s1 hello world, and if you want to encode it using ASCII or Unicode, we will write s1 dot encode, and inside bracket we will pass encoding method. Okay, so let's execute it and see how it looks like. So as we can see, string object is converted into the byte object, okay, according to the given encoding schema. Okay, now as we explained earlier also, that by default Python strings are Unicode, so it supports Unicode character represented in hexadecimal also. Okay, so this is non-ASCII character. So let's first see what is the output of two characters which are represented in hexadecimal. So if we print it, it represents its textual representation in Unicode. Okay, and these are the Unicode code point for that particular character. Okay, so this is how the Unicode characters are represented inside the string. Okay, so if we encode that same string using UTF-8, means Unicode, let's see how the output looks. As we can see, comparing with the original string, our original string is this, it is encoded as this in bytes. Okay, and if we check the return type of this object, it will return bytes. It is a class of the object. Next method is decode. Now in order to convert from binary data to textual data again, it is used decode method. Okay, it takes one argument as an encoding schema. For the given encoded string, the original string is encoded with which encoding schema we need to pass. Okay, so as we have encoded UN and this Unicode character into this, let's again decode from the bytes data. Okay, so if we execute it, as you can see, we have converted back from the bytes data to the Unicode string. Okay, and the return type of object is string, so it returns string from the byte object. Okay, encode converts string to the byte object, which is represent the data into the binary. Okay, and decode returns the string from the bytes object. Okay, so this is an example showing that different encoding schema encodes differently for the same given string. So we are using cafe as a string, and we will encode the same string using different encoding schema. Let's see the output. As we can see here, different encoding schema have represented the same string differently. Okay, one thing we can commonly see in here for UTF-16 and 32 is the BOM, which is appended same. So the character begins after the BOM. This is BOM. Its full form is Byte-Order Mark, which marks the beginning of appended at the beginning of the string, and it represents the byte order of the given string. As we have explained, the byte order can be little indent or the big indent. Okay, so as we are on the Intel CPU, it will be represented as a little indent. Okay, so that extra information is padded with the given string, that is called as a BOM, byte order mark. Okay, so that brings us to the question that we had a string representation, why we need byte object in Python. So we can convert it into the string into the byte object and store it inside the file object, but as a developer, why we need it? So to answer that, we don't only use textual data. So non-textual data are such as images. Images contains the values for the colors, okay, which are not represented into the text. It can be represented into the number, okay, which are binaries. Okay, network stream data is represented into the binary. Okay, video can also be. So byte object is used for transferring such data. Okay, so you can transfer that byte object over the network also. Okay, so let's construct the byte object. So this is the constructor of byte object. It takes first argument is a string from which we want to construct the byte object. Second argument is encoding schema. Okay, so that encoding method will be applied to that string, and the result of that encoding will be stored inside that byte object. Okay, and last and optional parameter is an error. By default, it is set to the strict, which raises Unicode error when encoding for a given character in the string is not found in the encoding method. Suppose we are representing some Unicode character and encoding that Unicode string using ASCII. So definitely ASCII encoding schema does not have that mapping for such character. So it will raise that error. Okay. So if we want to silent it, we can pass other value, ignore, okay, or replace and other methods. Okay, so let's construct the first byte object. So this is how byte object ABC represented in ASCII is constructed. Okay, so let's execute it. As you can see, in compare with the string object, small b or the capital B will be appended before the string, which represent the byte object. Okay, which represent the object of bytes class. Okay, so we'll call as a bytes. It can also be declared with the string representation prepended with b small or capital. Okay, so same schema is used. So inside single quotes or the double quotes or the multi-line string, same we can use for the byte object. Okay, so if we execute it, as you can see, instead of string, it converts that string into the byte object. So for this, it will be a Unicode string. Okay, by default it will convert into the Unicode. So similar to the string object, byte object is also immutable object. Okay, so if we compare with the string object, it also contains the same methods of the string in compared to the bytes. So if we compare the methods of byte object and the string object, let's see what are the differences. So in order to check the methods or attributes of a given object or the class, dir method is used. So it will return the methods, okay, and then we have converted into the set and we have taken the difference of between two sets, okay. So let's execute it. As you can see, these are the methods of string object which are not available for the bytes object, okay. And byte object in comparison with the string object, 3 methods are unique, okay. So string object obviously have more methods. So those methods are similar to the string, as we have as we have explained into the string section, okay. So that remains same for the byte object. We will see the methods which are not covered into the string session, okay. So as we have explained, dir on any string object, it will return all the methods of a string object, okay. We need to for now we need to ignore the methods which are beginning with the double underscore. We will explain it into the object oriented programming session, okay. So considering the methods other than that, these are the methods of a string object because we have provided an object of string. Alternatively, we can also pass the name of the class, which will also return the method of the given class, okay. And if you want to see a documentation string for a given function, we can pass that function within the help function. So suppose we want to check fromhex methods documentation of a bytes object, then we will pass bytes.fromhex inside the help, and if we execute it, we can see here the documentation for the method, okay. So let's begin with the first method, which is hex. It returns the string object containing 2 hexadecimal digit for each byte in the instance, okay. So suppose we have hello world as a byte string and we convert it into the hexadecimal, okay. So it will look like this, okay. So for each character it will return 2 hexadecimal value, okay, by default. It has optional argument separator. So if you pass a single character as separator, it will append the separator for each character in the given string, okay. So if you execute this, as we can see, it will append after each character. So if we see original string hello world and convert it, h is represented as a 4 and 8. After that it will append separator for same as for each character, okay. And the second argument is bytes per separator. If we provide that argument, it will take the given number of bytes to provide a separator. So if we execute it, as you can see, it will, if given 5, it will take 5 bytes, okay. So 1 2 3 4 and 5 from the right hand side, and it will, after the 5 bytes, it will append the separator, okay, until the end of the string, byte string. The next method is a fromhex, which returns the byte object from the string containing hexadecimal value. So from the same string constructed from hex, if we pass it to bytes.fromhex, inside it will return a byte object. Okay, as we can see, this is a byte string or a byte object. Now, as the strings and the byte object are different object, we cannot mix with the operator. Okay, so if you write string plus byte object, it will not append it. Okay, it will raise type error. Okay, it can only concat string with string and bytes with bytes. Okay, so if you append bytes to another byte object, it will give the same result as a string. So it will combine that string and return a single byte object, same as a string. Okay, so let's understand the immutability of a string and a byte object. As we explained in the string session also, that when creating a new object or modifying the object, string object, it will create another object. Okay, it will not modify the value of the given string object, because string object once constructed with certain value, it cannot change. So suppose we are iterating over a to z character in this loop, and at each step we are appending single character at a time. So in the first iteration we have initialized variable with none. Okay, so in the first iteration we are appending a, in second iteration we are appending b up to the last character of alphabet z. Okay, so result string will be character from a to z. Okay, so if we execute it, as you can see, it has constructed a string which is containing alphabet up from a to z. So it will loop over the 26 time. But here problem is, it will construct 25 string object. How? First of all, it will create a blank object. In first iteration, it will create object with a value. Okay, in second iteration, it will create third object which is ab. Okay, in next iteration it will create another object abc up to reaching the last character. So when we exit the exit the loop, it will have 26 string object inside the memory. Okay, so this is a waste of the memory space. Okay, because strings are immutable, so if we are changing it frequently, the same string, it will not perform optimally. Okay, so in order to avoid such number of intermediate string, we need mutable object to represent a textual data. So for that, solution is ByteArray. So ByteArray is a mutable object which can store both binary and textual data. Okay, so let's construct the ByteArray object. So first constructor is takes two argument, string and the encoding, and it will return the ByteArray object. Okay, as we can see, ByteArray object is represented like this. And the next construct, okay, so it takes an optional argument errors which has same meaning as we saw in the earlier into the bytes constructor. Okay, okay, so the second constructor is which takes the byte object itself. Okay, so if you provide byte object also it will construct the byte array out of it. Okay, So as we have explained earlier, byte array is a mutable object, so we can change the internal value of an object without creating a separate object. Okay, so when modifying the value of the given object, it will not create another object but modify that object itself. Okay, so if we have a byte array object which contains hello world encoded in ASCII encoding, and if we change its first character using byte object, okay, it will not allow that using byte object. Okay, we need to provide ordinal value of the given ASCII character in order to modify a single character of byte array. Okay, so suppose we want to modify any character at given index, we need to pass ordinal value of that particular character we want to replace with. Okay, so we want to replace first character with capital H, so we need to pass the ordinal of capital H. Okay, so if we create, first we will create the byte array. Okay, and this is the ID of that object. Okay, and next we will modify it, the first character, and let's check again the ID of the object. Okay, so let's execute it all together. Okay, so we have constructed that, and if we print the ID of that byte array object, hello bytes, it is printing an integer value. Okay, and after modifying the first character using ordinal value, it is represented in the capital H. Okay, and its ID remains the same, so which means that bytes array is mutable object. Okay, it has not created another object, it remains, the object remains the same because it is pointing to the same memory location, but its value is modified. Okay, so if you pass, instead of ordinal value, if you pass the byte object which containing a single character, it will raise an error. Okay, now this is replacing single character. Now if you want to replace multiple character, we can give that indexes into the slice. Okay, so suppose we have same byte array hello bytes, and we want to replace, we want to attach from 11th character, we want to attach array. Okay, so we will write from 11 index to end of the index, append the given byte string. Okay, so if you execute it, as we can see, 11th index is exclamatory. Okay, so from that index it will append the given byte string. Okay, so the sentence become hello bytes array instead of hello bytes. Okay, now in order to modify single character using single byte object, we have to pass slice of a single character. This sounds really silly because with the given index we cannot replace a byte object containing single character, but the one length of one index slice we can replace the same thing. So if we want to replace, so currently it is holding hello bytes array and h is in small, and we want to replace small h with the capital, we can write 0 to 1, which means a length of 1 character, and we will replace with 1 character byte object. So if you print it, as you can see, h is become capital. Okay, for the same object. All right. So in comparison with the string object, what are the different method we get with the string object? So let's compare with the string object methods. So as we can see in the output, these are the methods of string object which we won't get with the bytes array. All the others method works same for the bytes array also. Okay, and these are the methods we will cover in this session because they are unique to the bytes array object. Okay, because it is a mutable object, it has certain method. Okay, different method than the string object. So first method is append. Append takes one argument, it is integer, which is an ordinal value, which appends the single byte to the end of the byte array. So generally byte you can imagine as an array of a byte. Okay, so bytes can be represented into the integer character also of 8 bit. Okay, up to 8 bit. So we can pass that integer value which can be converted into the binary while storing or transmitting. Okay, so if we have byte array hello world, and if we want to append a single character or single byte, so we can provide integer representation of that single character into the ordinal to the append method. Okay, so as you can see, it will append a full stop to the given byte array. Next method is clear, which removes the all data from the byte array. Okay, so as we execute it, clear will remove all the character from the byte object or any binary data from the byte array. Next method is a copy. Copy returns the copy of the new byte array, copy of a byte array object. So if we have byte array object hello world, and if we copy that object into the another variable, both of them will be pointing at the different memory location. So if we print id of b array and id of b copy, it should point to the different object. Let's see. As we can see here, we have created a copy of a binary b array object which containing hello world. Both of the variable containing same value of a byte array object, but they are differently stored into the internal memory. As we can see, their memory address or the ID is different. Okay, so if you modify one of the variable, it will not affect the other. So we will modify the copy object. Okay, and we are replacing the whole string with this string. Okay, so let's check the output. As you can see, we have replaced the whole string for the copy object, but the original object remained the same. One thing here to notice is, now when we are modifying the immutable object, we are not storing the its memory address to again into the variable. Okay, we will see into the another method also. Next method is extend. So as we can see here, after applying this method extend, we are not storing the memory address of the returning object into the same variable. Okay, in order to take effect. So while applying the same function, suppose uppercase or the lowercase, we need to assign that return object to the given variable for the immutable objects string. Okay, but for the mutable object such as ByteArray, when we are executing that operation, any operation, it will modify that particular object. Okay, so let's begin with the extend. So extend will append the given ByteArray object or the byte object to the end of the given byte. So suppose first object is a hello and second ByteArray object is world, and if we execute ba1.extend, and inside we are providing the second variable, so it will modify the ba1 variable without assigning like this. So if you want to modify the same string using this, we need to write like this, but for mutable object we don't need to write like this. Any method, if we are executing on that particular object, will modify it. Okay, so let's see the output. As expected, hello world becomes hello world, and if we print the ba2 object, it will remain the same. Okay, same way we have passed the byte array, we can also pass the byte object. So if we provide the byte object, it will also append that given object to the end of the string. So as we saw earlier, this method has appended the world already. Now again extending that same object will append the given string to the appended object already. Okay, so it remembers the result without assigning back again to the variable name. Okay, so that is the main difference we need to keep in mind when dealing with mutable and immutable object. Okay, next method is insert. Insert the given byte or integer at the given index. So we can place any certain character at the given index. So if you want to insert L at the third index, we have to pass insert at the third index and the byte, okay, which is represented into the ordinal value. Okay, so let's execute it. As you can see, L is appended at the index L3. Next method is pop. It takes as a index as an argument, removes and return the byte at the given index. So suppose we have string hello world and we want to pop the character or the byte at the position 6. So it will be removed from the string and it will return that character. Okay, but the character will be represented in the ordinal value as we are passing the same value into the ordinal. Okay, so we need to convert it again to the character using chr method as we saw earlier. Okay, so if we execute it, as we can see at the position index 6, w was there, so it is removed from the byte array object and it has returned as a ordinal value, which is converted back to the character using chr method. Okay, so if the index value is not given to the pop method, it will remove the last character and return that. As we can see here, it will return the last character and remove from that byte array. Next method is remove inside the byte. So removes the byte, given byte or integer ordinal value from the byte array. Okay, so suppose we have string hello world, and if you want to remove w, we will write barray.remove an ordinal value of w. Okay, so this will remove the w from it. So if we print again after removing, as we can see, w is removed. Okay, and it will raise an error if the given ordinal value is not found into the given string. So suppose right now in the string w does not exist, and if you try to remove that w, it will raise value error, so it is not found in ByteArray. Okay, and if a given byte array is having multiple occurrences of a given byte, it will remove the first occurrences of that particular ordinal value or the character. Okay, next method is reverse. Reverse is the byte array. So suppose we have given byte array hello world, and if you execute reverse method on the given byte array object, it will reverse the value of it. And after reversing, if we print it, as you can see, whole byte array is reversed. Next method is hex. It is same as the method we have explained in byte object. Okay, so same argument, separator, bytes per separator. So let's execute that method. As we can see, it will convert two hexadecimal value for the single character. If you pass a separator, single character separator, it will separate each bytes with the given separator. And if you provide the third argument as a number of bytes, it will, if as a 5, it will gather 5 bytes, and after 5 bytes it will separate the given byte array. Okay. Next method is decode, which returns the string object from a given byte array object. So when we have a certain string and we want to modify it frequently, we can convert that string into the byte array, and when the changes are made, frequent changes, we can again convert that byte array object into the string using this decode method. Okay, so when we are creating byte array object, we are providing encoding. Same encoding method we need to pass as an argument of a decode method. So when we decode it, it will return the same string, or if you modify it, we can return the modified value, and return type of an object is string. Next method is fromhex. Returns the byte array object from the string containing the hexadecimal value. As you can see, hex contains the string into the hexadecimal representation. Same representation if we pass to the byte array dot fromhex method, it will return byte array object. As you can see, hexadecimal values are converted back into the byte array object. Okay, so these are the new method in comparison with the string object. So as at the beginning of the byte array, as we saw the example of a string, same example if we execute with the byte array object, it will only create a single object into the memory, which gets modified with the multiple iteration. So for the same A to Z, it will create a single object and append it to that object a single character at each iteration. Okay, that brings us to end of the session.